Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else calls me Damon. Got some PlayStation 4 power supplies that I bought on eBay. Here's a list of them, but we'll show you the picture right here. Got 8 of them. I bought them from eBay. I made an offer and it got accepted and got delivered. I'm not going to show you the totals because we'll see if we can get these repaired, how much I got in it all, and then if somebody can use them and see if we make a couple dollars off of it so that we can buy some more and keep doing this and keep doing a little learning. I'm enjoying fixing some of these older consoles now that the new ones are coming out. And getting a little practice in here and trying out some stuff and getting some new equipment. So I've really been enjoying it. So these were listed as a lot of 8 PlayStation 4 power supplies defective parts repaired. Includes these following 8. So you got 4 of the 200 watt of the N14s. 1 of the 200 watt ADP ERs, 3 of the ADP 240 CRs, and it says no repair attempts. Most of them, if not all of them, have had a bug pest problem, and you're going to see that because we're going to open them all up, we're going to number them, and then we're going to clean them, and then we're going to start repairing them. And they are buggy, woo, nasty, except for one. Surprisingly, there's one. So if you catch it, that was clean. And so I've got those written down. We'll get to cleaning them, or the cleaning footage. And also in a PS4 that I have that I've repaired, I've got an ADP 240 AR, which is the 5-pin model of power supply, and it's missing part of its case and everything. So we're going to steal it from one of these because the cases are the same. This is just 4-pin version of this basically. So we'll probably do these 3 first to see if one of them's really bad and it would just be a better candidate to steal the case from and turn into a parts or an experiment later on. And then we'll fix this one up that goes back into my working PlayStation 4 so that it will be all correct. And then we'll do these others also, and we'll see if we can I'll attempt to talk through. I'm not an expert on modern switching half-bridge power supplies, but that's what these are. I'm kind of a little more familiar with older stuff. I'm having to bring myself up to the date and up to the times with all this power factor correction that they've built into them all and everything now. But we'll try to talk through them and make a little sense as we go through of what it does. And I'll try to identify the components if I can, the best I can. It may take a couple videos to completely finish this off, plus we kind of want the results. If I can sell a few, and then maybe we can buy a few more and do something else. So let's have some fun with this, and let's get to cleaning. Okay, so I looked at all the ones I labeled and I've got them written out here. The 3 that I've starred are the ones that I might be able to get the parts I need for my AR power supply for my actual PlayStation. Put a W here for this one for the weirdo because we only have 1 of it, and so we got 4 of these. So I'm thinking we grab these 4. What's the chances of us having one actually maybe accidentally be working and use as a reference for the others? I'm going to grab some tape, label the board itself, and so we can set them out here and not lose the numbers that they were from the cleaning video. So let me do that and I'll be right back. Okay, it is, oh, you can't see that, number 1, number 6, 7, and 8. So let's just start out with some simple stuff. I'm going to slide 1 up here, 6, 7, and 8. I know, let's get them all turned the same way. So we get our multimeter. And word of warning, mains voltage goes into these. Now these have been setting and they're all good. Well, let's take our multimeter to 600 volts DC and we're going to check for safety. So you can see here, you can only not see number 1. And we're going to go across, see this capacitor? Maybe better in this. It's got 2 legs. This is the main capacitor that when the AC gets rectified and brought in, this is going to be the capacitor that has high voltage on it. If you look at it, this one you can't see, none of these can you really see it. It should have a rating of at least I can see it here, 450 volt. So it needs like at least 270 volts or so just for the AC stuff, and then it can spike due to when unplugged, due to the coils collapsing and causing reverse voltage to go in. So even after you unplug it, the voltage can go even higher than what it can whenever it's normally working. So you'd put your meter across the legs and you're wanting to make sure it's discharged. Okay, so they're all discharged. Now somewhere across here, hopefully, let me look with my eye loop here. Make sure that is that. I'm not seeing a real good quality discharge resistor, so normally it's kind of high wattage, but it's high resistance, you know, something like this one right here, to help discharge these when the power supply shuts off. But being this is all enclosed, one in its own case and then inside of a PlayStation, they may not have added that feature to allow it to have less inrush on that, and I'm not sure about power factor correction and all that other stuff. But easy thing to start out with, we'll put our meter on the continuity. And we're going to check the main fuses here. That one's good. That one's good. That one's good. And the number 1 that you can't see, we could stick it over here to the side, I guess. It is not good. So it's got a problem, possibly. Something caused the main part of the power supply to pop on this one. Now let's see if we can slide everything over to get it in the camera shot just a little better. So next, we have a little fuse here. This one's no good. This one's no good. This one's no good. But that one's good. So this one may have a problem over here in the main part of the power supply, and these all seem to have that part may be good, and a problem into the secondary. So you flip this over, and if you look, right, come on, focus. Yeah, see how it says primary over here, secondary over here. So this is the secondary side. This is going to be the low voltage 5 and 12 volt side. This whole side over here is considered the high voltage main side. So this is where you really need to be careful, making sure this cap is discharged and stuff like that. Other caps can hold high voltage, and you can get zapped and you can hurt yourself, or worse. You'll notice that bridging this little line between primary and secondary, the only thing that's bridging it is optocouplers. They have no actual physical connection. They use light as a on and off signal back and forth to tell these two sides what's going on. The only other thing that bridges it is transformers, which have no actual wire connection from one side to the other. They use the magnetic properties of a transformer to transfer energy, so there's no actual physical wire connection from one side. And the only other thing is a safety capacitor here between the primary and secondary, and that's for interference, and that's going to be like a class Y1 or X2. It depends on which way it's supposed to go. Safety capacitor, and all that means is these capacitors are specifically designed that if they get damaged, if they go bad, anything like that, they're designed to instead of being going as a short, they blow open so they can't cause a short. So that's why they're called a safety capacitor, and those are used, even over here in the power supply and stuff. So and they're for interference and stuff, but they're a safety capacitor because they'll be going between ground and mains and stuff, where they can go from the primary to secondary, and you have to use a safety capacitor. So let's go from here. We knew these 3 fuses were good, these 3 fuses were bad, right? Double check that. Yep. But this one was good here, but bad there. So this one's the oddball. Let's go ahead and just slide it out of the way for a moment, and we're going to take each board and do an inspection, and I may skip the time it takes here. Okay, I looked both sides of the boards over, and one thing I've noticed, these resistors right here are burnt on all 3 of these. So we're seeing a pattern, which is kind of cool that we have so many to work on here that we can see a pattern. But these resistors right here are burnt, and those resistors lead to this transistor. Excuse me, on all 3 of these, and so this is going to be on this power supply. This is the 5 volt side. This side, the bigger side, is the 12 volt rail. So here's your 12 volt out, and here's your 5 volt out. And so let's do a quick explanation of kind of how this works. You have some control chips that's going to be doing some different things. Some of these may just be regular control chips. Some of them may be, when I say regular, I mean a pulse width modulation for a switching power supply chip. Some of them may be a power factor correction chip, and I'm not sure. This is a lot of. In the old days, you'd have one chip running this side. You'd have one, maybe 2. Opt amps providing feedback from the secondary side, and there wouldn't even be control chips over on the secondary side, except for maybe a voltage reference, which was telling this to turn on, which would shut down this side when the voltage got too high, and then it would turn this back this side back on when the voltage dropped, and it would do that really fast. That's what a switching power supply does, is it does all this really fast. And it switches, it pulses it out, but it does it so quickly that it seems like to most everything that it's a pure DC, and especially when you add some filter inductors like this and filter capacitors, which smooth that out. So what happens is you get mains come in here, you got fuse for protection. Looks like you got either a cap or an MOV or something like that for either inrush, or it says VAR1 a resistor, so it may be for inrush. It's going to come in through this inductor. So I'm going to look at this and kind of tell you how it goes. It's got filter cap. The neutral side is actually going through this MOV, which is also for inrush limitation. And it goes through this coil. Hang on, I'm having to look. Those are your safety caps, and that's one from one side of each, and they go to this ground point right here. And they're jumping from one side of the rail to the other. Goes through those all the way over to the bridge rectifier, which is here. So all that is filter. That is filter and inrush limiting and some safety stuff to make sure that there's not a lot of interference generated as you're changing the AC to the DC from the line in. As we go out, we got another filter cap and a filter coil. And this is your switching FET, I'm assuming. And there's a rectifier. So I would say this is not normally how the old-fashioned ones work. Normally the old-fashioned ones would have this. You would have a FET or two switching on and off through a transformer like this or this, which we do. We still have that. They're here. But I think with the power factor correction, they're switching on and off and running through this diode to provide to keep your DC a little cleaner, maybe to throttle it or something, to do something with the power factor correction. But that's going to be switching. That's going to be rectifying it, because this is a diode, a D3 right there, and it just got two legs. And this is your main cap for smoothing of that DC. So you're going to get a really high voltage DC coming out here. And then that should go in two different places. Should go over to this side and this side. This side is this little FET, which I'm going to assume is controlled maybe by that one right there, is going to switch this little transformer and go out here, and this is a diode. It's going to get rectified here, so, and then smoothed by this cap, then filtered by that inductor, and then smoothed again by this cap, and that'll give you your 5-volt standby. These two FETs are probably going to be switching this one, and they got a filter cap there. And then these are labeled as Q. I was kind of looking at this. I'm going to have to look that number up maybe before we're all said and done on this. Normally I would assume there would be a diode there, but maybe they're switching that, or I'm not sure exactly how they're doing that with the control of it all, because we do have a whole nother control chip. So they're doing some kind of pulsed DC, which is getting smoothed by caps. There's another inductor here and another filter cap, and there's your 12 volt. So let's jump back here for a second. We noticed damage caps here feeding this side here. That's all the physical damage I seen. We knew these three, like I said, this one over here, this oddball, we're going to leave it for now. But let's test. You can test FETs, since those resistors are there, to see if it's shorted. So if you was to look at that FET, its little legs are right here. So let's Nothing. Oh, that was me slipping. That one tests okay. So number 8 says okay. Make sure I get the right pins here. Aha. So that one's showing short. And yep, this one's got short there too. So at least on these two, what it appears is that we've got a problem here feeding the 5-volt rail. So we need to check the output diode here and make sure it's not shorted. So it should be shorted leg to leg on the outside legs, but not to its output pin in the middle. Now see that when your meter does that and beeps and you think, oh man, I got a short, but then it goes away? Let me do that. Here we are on a diode. It's going to beep like we have a short. Oh, let me switch them. But watch your meter and it goes away. What that means is there's a cap charging. That's this cap right here. And so this feeds out to that capacitor, and a capacitor will show a dead short when you first put your multimeter on it in diode check. It'll beep like it's a dead short, but then it'll go away and you'll see the number climb. And so if we do that and you watch that number climb, it'll go all the way up to a 1 like it was nothing, like it was totally open. That means that cap fully charged, and that's what 3 volts or under is what most multimeters put out. So these two definitely got a problem on the 5-volt rail. Did we check this one? This would be the diode here. That's okay. Check it the other way. Yep, it's okay. And then I would check for a short on the output here. So we need to go ground, which you can use the same ground for both these, but our 5-volt standby, we want to make sure that's good. So we go to ground here and 5-volt standby. That's okay. And then on this one, ground, and these are labeled on the board, 12-volt or ground, so that makes it nice for us. And our 5-volt standby, and neither one of those show shorted across. So I think everything's okay on this part of the 5-volt. It's just this one died. Now these being bug infested means they can die for crazy reasons, because you just never know where the bugs got in. When I was cleaning them, they all seemed to like to be down here on the secondary side, and so they could have just been on the circuit boards. It was all nasty down here, but they could have just bridged across somewhere with their bodies and pulled too much current, especially because the 5-volt side's really weak. It's only designed for like 1 amp or less. If I remember looking at some of the stuff, and so it's pretty easy for that to happen. And if they, depending on the design of the PS4 and stuff, if that's just how the bugs happen to congregate in that area, you should kind of see the same kind of fault repeated. So this is kind of actually what you would assume would be typical, is that you got an all bug power supplies, bug contaminated, and then you clean them all up and stuff. You should see how the same thing, a repetitive thing. Now this one, we checked it. That one did not test goofy. So supposedly that FET's okay, but this fuse is blown, and those 2 low ohm resistors that feed that FET, one of them is definitely blown, and the other is not very good. So they're really low ohm, so we should get an ohm reading. We're going to look at an ohm reading across there, and we get nothing. And those two are in parallel, by the way. When you look at them under your eye loop, you can see that. And on this, we get nothing. Now, If you do this one, these are not blown on this one. Remember, this one's the one we may have a problem over here. You get a reading, and we get really low because they're both what is it again? 1R8, so that's 1.8 ohm, and they're in parallel. So technically they should give you 0.9 ohm, and then my multimeter leads, so we're getting 1.2, and my multimeter leads are about 0.2, so that's about right. So what I'll do is I will we'll get these off here. I'll double check whichever one this one wasn't bad in, but we're going to get that out. We'll get the fuses all out, play a little music, fast forward it, and I kind of really, if this is the one that's this supposedly checked good, I kind of really want to replace this, but maybe we'll take the chance and not replace it. We will replace it in the two that shorted, and that maybe will give us a reference. Maybe it'll pop those resistors again because maybe this thing has got damaged or weak, and you guys can't even see it there hardly. So two of them we know is definitely bad. We'll definitely replace those. We'll replace the fuses, replace those resistors. We'll do the resistors on the bottom and the fuse here. We'll leave this one here, and we'll see if it actually is weak or if it gives us 5 volts out, if it survived. Otherwise, if something goes bad and it pops a fuse and does all that again, we'll think it's there. Once I get all that swapped, then we'll get up here and we might be able to plug some in and do some testing, and we'll talk about that, and then I'll show you those voltages. Whenever the power supply is on, we'll be real careful there, and then I'll show you the voltage spiking up when you've disconnected the power from it. So give me a minute to get set up with desoldering and stuff, and I'll play a little music while we get all this stripped out and changed. I'll go ahead and solder in the new pieces.